Welcome back. Looks like the sun's out. All right. All right. So, young gentleman who's been asking a lot of good questions. Do I have your permission to use your first name for the rest of the semester? You strike me
Yeah,
as a
that's fine.
gentleman who would not mind.
Yeah,
All
that's
right.
fine.
Can I introduce you right now? Just your first name?
Yeah, go ahead.
Everybody, this is Hassan. He's asking good questions, and I expect he will continue to do so, possibly starting right now. Do we have any of the students that are here have another question for this week's Q&A?
Mike, so for I'm like having difficulty with the primary, secondary, and tertiary aminos, like in distinguishing.
Okay. All right. So we're into functional groups now. And you see classifications for the following 3 functional groups. Once again, this is the introduction to functional groups at the end of chapter 1. And I want you to know ahead of time there's hundreds of functional groups. We're sticking with 8 major functional groups, and 3 of them get numerical classifications. 3, well, hold on a second. Yeah, 3. 3 functional groups with numerical classification.
Oh, we can't see the board.
Oh, yeah, that's right. Well, thank you for pointing. And yes, please always feel free to interrupt when that is the case, because I often don't know where I am. 3 functional groups with numerical classification. So I'm taking your question and expanding it a little because I think it'll help everybody. Now, when we look at alcohols, I know you didn't ask about them, but I want to early on this to not be a point where students lose points unnecessarily. Alcohols always have carbon bonded to OH. O will always have 1 bond to carbon, okay? Unlike nitrogen, which could have 1 bond to carbon, 2 bonds to carbon, or 3 bonds to carbon. So when we're classifying alcohols, you classify this carbon. And there's 4 possible classifications. If there are no other carbons attached to that carbon, you have this molecule, and the classification is methyl. It doesn't even get a number. And if you have another one like this one, CH3, CH2OH, or even a little longer, CH3, CH2, CH2OH. This carbon and this carbon are the ones you used for classification. That's following the instructions here. They each have 1 more bond to carbon. It's always bonds to carbon equals primary. Here's the word. The symbol is 1 with a degree sign above it, and that R doesn't look like an R. And we can do a stick figure just to be sure. We can even have other carbons at a distance there. And the carbon in question is only the carbon attached to the OH. There. Didn't want this little dot here. There we go. So primary, we have methyl and primary so far. Secondary, I'm just going to go straight to stick figures to save a little time. We have this or this. So that's the carbon we care about. That's the carbon we care about. And these are secondary. Why? Because that carbon has 2 more bonds to carbon. This carbon has 1 more bond there and 1 more bond to carbon there. This carbon has 1 more bond to carbon here, 1 more to here. This will not change the answer. Doesn't matter how many carbons this has to bonds this has to carbon. It's only this carbon that I care about. And I don't want any little discrepancies. There's that little stray mark. Early on my stick figures, I want to make sure there's no stray marks there. I was just saying, why is that little thing sticking off of there? I don't want you saying that. And tertiary is our last category. A couple stick figures for that. The simplest tertiary would be something like this. And a little more complicated, but not really different. You can have it right there. The carbons in question are this carbon and this carbon. And we call those tertiary. So when you classify alcohols, you don't look at the O. First, you got to see an OH to be an alcohol. You got to know that. Later on, you're going to learn about carbonyls too. And you see this carbon cannot be a carbonyl. It's right there in the textbook, right there in the videos. It cannot be a carbonyl. Some of you don't know what carbonyl is yet, which is cool. Just wait till you read about it. But for now, an OH attached to carbon is an alcohol, and alcohols need a number or a word. The word is methyl. That's a very specific example there. Primary for a carbon that has only 1 bond to carbon, 1 bond to carbon, or secondary for a carbon that has 2 bonds to carbon, 2 bonds to carbon, tertiary, 3 bonds. Then you get into the amines and the amides. That was our Hassan specific question. Amines and amides both follow the same, a different pattern than alcohols, but the same pattern as each other. Nitrogen can have up to 3 bonds to carbon. Amines there, C, C, C. Well, it doesn't have to have 3. It can have 1, 2, or 3. We're going to get used to using R's. Amines have to have at least 1 bond to carbon. If they don't have 1 bond to carbon, then they're called ammonia. You remember that one? NH3. It's not organic. R can be carbon or not. In fact, you could have different R's. R is a organic chemist's version of what we call a variable. And it's understood to be carbon, a carbon group, unless you're told otherwise. I'm telling you here, R equals C or H. There's the otherwise right there. Now to be an amide, one of the carbons has to be a carbonyl. Okay, that's a carbonyl I just drew there. Carbonyl, C with a double bond to O. You'll be reading about it hopefully before the end of this week. A carbonyl is not a functional group, okay? It is part of a functional group. In fact, it's part of 5 of our functional groups, amides being one of them. So amides are over here, amines are here, and we're not done. But Hassan might have a illustrative question right now.
For the carbonyl, isn't there usually a hydrogen attached to the carbon?
No, that could be another variable here fitting the same description. I'll call it R double prime, R or R prime or R double prime. Can be C or H. Doesn't have to be an H there.
Okay.
And let's just look at some categories. For amines and amides, you count up the bonds from nitrogen to carbon. Unlike alcohols, if you did that same system for alcohols, every alcohol would be called primary because every alcohol has one bond to carbon, one bond to carbon, one bond to carbon, one bond to carbon. That's why it's useless to use that system here. Later, when we study alcohols, you realize, oh yeah, he taught us this system because those alcohols have slightly different behavior. So we have to be able to classify them so we can talk about them. Amide, same story. Let's do a simple primary amine. These are all primary CH3, NH2. That's methylamine. We could have a straight chain NH2. We could have this. Yeah. Hey, if that was an alcohol, you'd call it secondary because in an alcohol, there'd be an OH there and you classify that carbon. But in an amine, it has only one bond to carbon from the nitrogen, so it's primary. And then we'll go with amides in blue. We could have one that has just a carbonyl, and this is a carbonyl that has an H on it. Here's a carbonyl that has a carbon on it. Doesn't change anything. They're all primary amides. There's a very common group in organic chemistry called a phenyl. But the point is, all of these nitrogens in this above that red line have one bond to carbon. So these are primary amines. And below them are primary amides. Secondary, we can go diethylamine. Now, you can do it this way or write it like this. These are the same. You don't have to show a bond to an H. But please notice you can't skip these H's here. Unlike where here I skipped an H, and here I skipped an H, here I skipped 6 H's. You're only allowed to skip H's on carbon. Don't find that out when you get your test back and you lost a point because you skipped H's on any other atom other than carbon on stick figures. So those are the same. Let's put one in a ring. Those are all secondary amines and amides. You get devious and just edit those. And there's another way to show. You can put the H there. You do know that H is not bonded to both the nitrogen and the carbon, right? That's not H's nature. So when you see it like this, it's bonded to the previous atom. Secondary. You have two different groups. And it's not an amide though. Change that to a carbonyl. And 3 examples just to be consistent. Notice that all secondary amides or amines have one bond to H. When you're doing the secondary part, it's bonds from nitrogen to carbon, which make it secondary. And nitrogen's nature is to have 3 bonds, so you better be putting an H on there. And tertiary. Tertiary. We can have, this is a very common base used in organic synthesis, triethylamine. Don't worry about its name. We could have This one here, that's secondary so far. I have another ring out here. Why not? And one more. Oh, look at that. Combining stuff. Fancy. So here you have both a tertiary amine. And this is very common to have multiple functional groups in a molecule. It's more common than not. And if I asked you what kind of alcohol was that, could somebody tell me? What kind of alcohol is that? Notice I pointed to the carbon as a hint. I didn't point to the nitrogen. The OH is what makes it an alcohol. This carbon has how many bonds to carbon? 1. So it's a primary alcohol in the same molecule as a tertiary amine. And we could have, this molecule is a very common solvent used in organic chemistry called dimethylformamide. Don't worry about its name. And what else? Got the nitrogen in a ring. Carbonyl there. Oh, these should be blue, shouldn't they? I don't think I can change their color. These are amides down here. Amines up here. I think 2 gets the point across. So that right there would be a nice little segment. 3 functional groups with numerical classifications. You got your alcohols, amines, and amides. So I'm going to leave it at that. I will come back again and have some good questions for our next segment. This one won't take as long to get rendered, probably back in 5 minutes is my guess. Okay, see you in 5.